In the last video, we built a basic security structure around our application, and the only thing that we implemented was how you can authenticate using username and password. Now let's extend it to a properly workable solution. Before we can do that, we need to do few things. Number one, when we are basically what we really want is that once a user has authenticated using your username and password, we issue a token, and then user can continue working using that token. Now when a user is sending the token to authenticate, we don't want him to send his username as well, and it is because of that reason the authentication token has to be unique across all the users, because otherwise we will not be able to identify the user. So we need to make our token unique across all the users, and to do that what we will do is we will take our username and convert it into a base 64 string and then append it to the token that we are creating. So the generate token method itself needs to take a username as argument, and then let's take a base 64 encoder, let's do base 60 dot get encoder dot encode to string. We will use the encode to string method, and we are never going to test it, though this is the only reason we are doing it, so that we can because the username will be prepended to each auth token, it will kind of provide us a little bit more of a guarantee that our auth token across all the users will be unique. So we take this and prepend it to our auth token that we already created. So this becomes our definition of new auth token. It basically consists of a username encoded to base 64 and then 2 random UUIDs, and we can pass this here. Now because we have made it unique across all the users, it is a good idea to also go ahead and add this constraint within our tables. So we go to user entity and we can add this constraint, so that at database level it is guaranteed that our auth token is unique. So yeah, this should take care of that. Now we want to allow users to authenticate using a token. Now if you remember what we did last time, we essentially created 3 classes, actually 2 classes. There was a principal and there was a provider. So similarly, now we need to create 2 classes for token based authentication. So let's first create a principal. So we go ahead and create a new class. It's token principal. We created that. And what should token principal contain? It should definitely contain the auth token, and I think for now that might be sufficient. So as you remember, we need to extend this class from principal, and then we need to define, it has to be implements, not extend, because it's going to implement the principal interface, and then we implement the get name method, and within the get name method, now we need to store the token somewhere. So to do that, we can just have a private string that contains the token, and so it will contain a token, and in the get name method we can just return that, because this is the name that we are going to be authenticating against. Now this is where an interesting issue comes up. Should we be really giving token as the name, or before we create this principal we do a database lookup and we actually provide the real username? So let's look at how our auth filter is defined. So we can go to project and look at our auth filter, and let's see what are we trying to do in auth filter. Now within the auth filter, if you really see, we expect in the username principal authentication, we expect the username and password coming through the headers, and then we essentially ask it to authenticate, and we are not doing any database lookup here. Now technically it is possible. So there is one issue. One is when the filter is called, by that time the Spring context is still not initialized. So because of that you cannot auto wire anything into this particular class, but we can use a manual application context, and if we really want we can get access to the database. The cleaner way is to do all that activity within the provider. So we will stick to that pattern, we will not do a database lookup here. So because of that our principal would just contain the token, and what we can do is when we go into the provider we will overwrite it. So let's look at how the provider code for username password looks like. So within provider, if you see, we are going to do a database lookup anyway, and after doing database lookup what we end up doing is we are creating we get the principal here, we look up everything from the principal, and then we are creating this user password authentication token with the principal. So before doing that we will override the real username into the principal. So let's do that. So we go to our token principal, and so what we do is we keep two different variables, one is the token and other is the name, username, and we will use username to return here. And what we are going to do is we define a constructor for it, and within constructor what we will do, we will have two constructors, one that gives us a username as well as token, and that is just simple, we assign both of them to their respective values, and we will have one constructor that only takes token, and if this constructor gets called then this will only get token, and if this constructor gets called we will assign both of them to the same value, because name cannot be null, because name is used by the Spring in multiple places. So we have to assign some value. To start with we will just assign the value of token to it, and we provide another getter for we basically provide getters and setters for token. A name does not need a getter. We can also provide for username itself, which we will never use, but just for symmetry sake we provide. So this becomes our token class, and yeah, and then what we do is now we define a provider. So to define a provider, let's start with the username provider, and we will modify that class to do our job. So we refactor, copy username password provider and rename it to token provider, and now we go and update it. So from the start it is fine. Now here we know when we are here we will get token principal. So we get the token principal and we have to cast it to token principal. Now we check if principal dot we don't need to call is present because we have not, actually we should use optional because that seems to be the way we have done it everywhere. So let's keep it in sync. Let's make it optional strings. So token we are changing to contain optional strings rather than just strings. And let's complete this. Let's get rid of all getters and setters. And we can generate new getters and setters. And here we provide optional string, optional token, and same thing we do here. So we change this to use optional. Now let's go back to our other class. So here we check if username is present and token is present. Then we get username using this and we get token using this. And then we have to find the user by auth token. Now this method is not written yet, so we will go and write it. Now if we get a auth token, then we find it. We don't have to do password match because in case of token no password match is required. So we get a user entity. We just need to check whether the auth token is equal or not. So we check this here. If OU is present, okay, let this be this way. Now after this we will write if UE dot auth token get auth token is equal to the auth token that is passed to us, which is token. If the tokens match, and UE dot get auth token dot get expiry, no, UE dot get expiry. If the auth token is not yet expired and the expiry is after the current time, so we take new date to show the current time. So basically if the auth token is equal and it is not expired, we go ahead and we don't need to set the auth token, we don't need to create all this. The only thing that we need to do is we need to return it, and to do that there is a class already defined that is called Pre-Authenticated Authentication Token, and it takes a principal, but here we don't want to return that principal. What we want to do is we take new token principal and we basically pass the real username here. Why we need to do that is because if we don't do it, later when we want to within the security context, later when we want to get the username, it will not give us the correct username if we don't set it within the principal. So first is we take the username and then we take the token that has come into us, and it needs optional string. So let's do, so this is optional anyway. We have to only call principal dot get token. Okay, UE dot get username is not that, so we have to do optional dot off. So basically we so now we have created this, and in terms of the roles that this thing is allowed, we just look at the user and whatever roles are allowed that we pass it. So the last line is okay. So now if you see, basically what we have done is we got a token, we looked up in the database that whether it exists or not. If it exists in database, then we check that actually we do not need to do this because this is how we got it by looking up from the database. So we can eliminate this one call. Only thing that we need to make sure is the expiry is after the current time, and if that is the case, I think we are all set. So now with this we can request valid, we can say either we can just say token was not present. Now once we have done this, we have to go back and define this thing in user repository. So we can just copy this old query, select UE, we can just say auth token equal to auth token. So basically we are querying. Here also we should actually pass param username, string username. Similarly we will pass it here also, param So now that we have done this, the only other thing left is in the supports. Now we have to say that this will support pre-authenticated authentication token. So now once we have done that, we need to, if you remember, we had the security config where we have to hook it up to say that this is another one that is available. So we go back to our list of classes and go into configuration, security configuration. Here we have to add it, and we can just say it is a token provider. Okay, so we added the authentication provider here. Now we have to define a bean for it. So okay, so we added the token provider there. Now we have to define a bean for it. So we provide a bean called token provider, and which should return new token provider. So we have added it here. Now I think the only thing that is left is that we have to hook it up in the code in authentication filter. So if you really see, this is what we are doing. Right now in authentication filter, our code is very simple, that if the URL is authenticate, then we go ahead and do this thing that we are doing, and we install the context. Otherwise we just continue. So what would really happen is that if you have any other URL apart from authenticate, it will just always go through the filter chain and succeed. So we don't want that. What we really want is, if the URL is not authenticate, then we are going to assume that we will get a token in the incoming request. So, same way like we had username header and password header, let us define a token header. And let us call it X token, and then here we will check the request should contain a token header, and then we create a token principal which is token principal, and it takes a token as an argument. And we pass token in both the parameters. Actually, we have a constructor that does that. Now we need it. Now we need to create a token which is basically the equivalent of username and password authentication token that will be used for used by Spring, and that basically is called pre-authenticated authentication token. So, that is our request token, and we call it pre-authenticated authentication token, and it takes 2 arguments. Basically, if you see the constructor of it has an object and a credentials. So, in case of token there is no credentials, so we can just pass null, and we sent a request down using authentication manager, and then we check if, so we got a response authentication back, and then we check if it is authenticated, we set it in the security context holder, else we throw the error, and then we let the filter chain run through. So, basically what will happen is that this particular authentication manager will go through our provider, and we will get a authentication back that will contain the new modify principal that we had provided. Once we get that, we can insert it into the authentication, otherwise we throw an exception. So, I think with this we should be set to see whether it works. So, let us run it. So, meanwhile we are launching Postman. So, let us first authenticate our user 1 using user 1 password. We send authentication request, and this is our auth token. And now what we are going to do is first let us go to our hello without any authentication, and that should give us a error. So, we send it, and right now it is giving us a 500 server error. So, let us check out why it is giving us a 500 server error. Okay, this is the error that we got. So, we are getting a null pointer exception somewhere. Okay, this is because we do not have the token header. So, we should actually throw a proper error here, but for now let us fix this by providing. So, yeah, so if the token is not provided, so if token dot is present, then only we do all this. Else, if the token was not present, then we throw an error, new bad credentials exception. The no token was present in the request, authentication failed. So, let us rerun it. there is a semicolon missing somewhere. Okay, server is up. Let's run this again. We still get a 500 server error, so let's check it out again. What has happened? Oh, okay, so the error is not coming here, the error is coming before that. So we have to say string token header equal to and then we can put this check before it. Actually, there is a better way of doing it. There is a variant of optional that will take a null. The regular variant doesn't take a null. So let's see what that is. Optional dot off nullable. I think this will guarantee that if the null value is coming in, it will set it here. So this should do the trick for us. The regular off method of optional expects a non-null argument, but off nullable will be able to handle null properly. So let's go back, run it again. We still get a 500 server error. Okay, so we did throw in bad credentials exception, but it should have mapped to let's see the raw. Okay, I know. So basically, as I mentioned some time back, that till the time you are in the filter really does not understand the Spring related things. So the bad credentials exception it will not be able to process, because it's basically it will just throw off an exception and it will show up as an error. So what we should do is we basically have to create our own packet to throw that error, and the best way to do it is right now if you see within the body we are sending let's change all this internal authenticated service exception to bad credentials exception, so that we have to handle only one exception, and then we can write a method that will handle that exception. And basically what we do is something like this. We define a private method, let's call it handle exception, and let this be void. And what this method does is it basically we pass it two things. It will contain bad credentials exceptions which we just defined, and it will contain a HTTP servlet response. Actually we can pass an exception here, so we can do for both the things. So now what we do is we check if EX is an instance of base exception, because that is the exception that we defined. Then basically what we do is we need to first downcast this. So let's say base exception BEX equal to base exception dot class dot cast EX, and then what we need from base exception is we had a message that was defined here, and we had a message, and then we had an error code. Let's look at base exception. What is that? Yeah, there is a, okay, we haven't defined the setters and getters, so let's define those. And as we know that error code is actually the same thing that we are passing. It contains the HTTP status code, so we can get it from here. The other option is we can also look at the annotation, because we are using annotation, but right now let's not worry about it. So we will just go back to our other class, authentication filter, yeah, here. So we get error code, so we can say int equal to this, and then we can get a message, and then we can define another method so it takes error code, message, and it takes servlet response. And basically what we do is we can define a class which is the format that we really want, and basically which will return as a response, because we want all the responses to look very similar. And the class could look something very simple, something like what we have already seen. Let it be something like basically let the class be something like let's go back to our exception package, and within the exception package we define a class. Let's say exception response, this is our class, and basically we know that every exception can contain error code, and it will contain a message, and let's say these are the two things for now. We will worry about, we generate getters and setters for this, and then we generate a constructor, and we also have to generate a default constructor. So now we go back to our authentication filter, and basically what we do is we generate exception response er equal to new exception response error code comma message, and once we have this we can set the, so first thing we need to do is in the response we set the status, and the status is going to be the HTTP status that we want, and here it is the error code, so we can just set it. So this will go into the HTTP response, and then we can create a JSON just to create a, this we are just using to create a response object. So string token response, or let's call it response body equal to dot to JSON, and this is our exception response object that we created. Then we add a header in, which is content type, and that header should be media type dot application JSON value, and then we can take a response dot get writer print, and we can print the response that we just created. So this will basically send the response onto our wire, onto the response object. And now what we can do is call this method from this handle exception. So we pass error code, message, and response. Now this is throwing an exception, so we will catch that totally in the object, else if ex dot es is an instance of bad credentials exception, then we do the same thing, bad credential exception BCE equal to bad credential exception dot class dot cast ex, and then int error. In case of bad credentials, we know what the error code is going to be, so we can just call handle exception messages http status dot it should be not unauthorized. So we say unauthorized, comma, message we will get from bad credentials exception, and then we say response. If it is something else, then for now we can just throw new internal authentication service exception, and it should not come here. We can just, this will return us 500 error, so we will know something is wrong. Now these two, if you see, there is an exception being thrown in the handle exception itself, so that we again have to catch here itself, because we can't send it up, so we just catch it. We can just add a catch clause, we just print stack trace, and we can throw this exception again, so that will take care of it. So now that we have this, basically we can call this handle exception from within. So the whole of do filter, we can encompass it within a try block. This is to make sure any exception thrown from the body of this is essentially caught here, and then we can catch, we basically catch any exception, and for that exception we just call handle exception. These two things we can move up. So here now we have done the exception handling. You have to understand, this exception handling is only needed to be done for everything that is happening within the filter. Once you go into the Spring context, it has a much cleaner way of handling all these exceptions which we have already talked about, using the annotation, and then it will automatically send the right HTTP response. So this is just to make sure that during authentication within the filter, if something goes wrong, how do we take care of it? So let's run it again. So now we are getting a 401 unauthorized, which is expected because we haven't authenticated it yet. Now let's go to our previous authentication request, and this is our token that we had got, and now send the same request by passing the token header. Now see, we get a 200 OK and we get hello world. So now it's very clear, if we remove the token, send the request, we will get unauthorized. If we send the token, it is successful. So I think this kind of completes the loop. Now we can add all the endpoints, and all the endpoints will be behind this authentication wall, and that will provide us a nice way of handling all the security related stuff in one place. We don't have to handle security for each and every endpoint call. There is still a lot more stuff left to do here, and I am going to make additional videos to handle those. But I think for now this completes a circle, and I don't want this video to become too big. So with that, I am going to close this video. If you have liked this video, please subscribe the channel, click on the bell icon, share it with your friends who might be interested in this, and thank you for watching this video, and see you soon with one of the future videos. Have fun.